I try to make sure that I've checked in with students first and that I'm pretty confident I know what they're going to say. Sometimes they still surprise me, but I'm looking for, they were able to explain to me as I was going around what strategy they used or how they got their answer. And then I usually try to warn them, like, I'm going to go ahead and call on you, or, hey, I already talked with you, so I know you've got something really insightful to say. And so I'm really thoughtful with who I call on. I try not to like surprise anybody per se, but it's usually because I know what they're going to say is really going to elevate our conversation and bring it all together or highlight something that I really want all students to make sure that they get by the end. All right, show me your thinking.
Well, in the middle of every one of them, there's just that square.
Interesting. So the square is showing up somewhere in the middle. How are you accounting for these pieces?
And again.
Say that again. Plus n again. Oh, wait, go back. What'd you just say?
And again, like
N squared plus how many n's?
2n.
Oh, does that work for all of them? Go back and check. Show me you're thinking that all of them works for their. All right, tell me what you got.
For what? Which one?
Is it quadratic? Is it linear?
Oh, I thought it was quadratic
Okay, how can you prove that?
because it like increases by like almost exponentially.
So can you show me, how would you show that? What would be your strategy to like prove to somebody what it's gonna be?
Put like on line with each step.
You wanna graph it?
Yeah.
So we said, okay, go ahead and graph it, okay?
We could draw it with the computer.
Oh, like putting in like a table?
Yeah.
Yeah, go ahead. Oh, how did you come up with that, Dylan?
Because
Show me your thinking there.
you can see that there's kind of like the
Okay.
main sort of quadratic thing there, and then there's always like 2 rows up top. So, and since they match like the number of like columns match the number of steps.
So I want you to hear what Dylan is saying here, where he got the n squared, right? Because we're talking quadratic. And then he said it's going to be n squared plus 2n.
Because it would be the step number multiplied by 2.
So can you add 2n to your n squared plus 2n? And notice the color coding helped us to really kind of visualize that. A lot of you saw the n squared at the bottom of this step, but noticing, thank you, Emily, as she went through and she was saying, okay, I can actually see that square in the middle. You saw 1 squared, 2 squared, 3 squared is what I saw you kind of coloring in. Yeah.
And then I saw that there was always like 2 squares on top, and like the columns of those 2 squares always match the step number.
Okay, listen to that line of thinking. There are 2, but the number of columns that it was the same as the step number. So it was 2 times n, because he was the one that reminded us that n is our step number. Awesome job. So as we're thinking through those, so was Kieran right? Is it linear? No, it's not linear. And then some of you, while I fully appreciate because we're in the middle of quadratic, it's probably quadratic. Yes, I mean, they're probably not going to throw in exponential, although they might. But that idea of how do you prove your thinking? How do you show? And then, did you end up graphing it?
Yeah.
Did it look like a quadratic?
Yeah.
Yes. So also from yesterday, being able to graph it and pulled out Desmos.